The next section we'll look at is called Structuring the Supervision Sessions. And really what we're going to try and do here is apply a different kind of project management approach to HDR supervision. I'm often reminded that the traditional bureaucratic approach to HDR supervision that we talked about earlier is very reminiscent of a Gantt chart, which is often a requirement that institutions have for students when it comes to planning the PhD project. Gantt charts look great and they do make you feel satisfied when you've completed them, but they're rarely, if ever, enacted the way that they're drawn. Gantt charts were invented around the First World War, and there's a joke amongst project managers that they know how well the First World War went. Gantt charts are not useful devices for planning, but there are other approaches that have been developed more recently that are, and we'll consider some of them in the context of HDR supervision. When it comes to project management, the gold standard for institutions and supervisors is on-time completions. And for supervisors, we want the work to be high quality, we want as few errors as possible. And these two issues of timeliness and high quality really necessitate thinking about supervision from the perspective of project management. And whilst we've bagged traditional approaches to project management that involve Gantt charts and waterfalls, there are alternatives that have been developed more recently that have been involved in business areas like software development and new product and service development that are referred to broadly as agile. So agile approaches to business development are useful to explore because they represent the state of the art in project management practice. Agile approaches have specific roles and responsibilities. There are product owners who determine what to build. There are development teams that determine how to build something and then go ahead and do it. There are customers that gain experience with what's been developed and otherwise benefit from it. What makes software development agile is that the value is delivered to the customers in small increments and feedback is collected from customers and fed back into the process. Well, of course, we don't really have customers and product owners, but we do have supervisory teams and we do have what we imagine are going to be the requirements that examiners will use, effectively the customers, for PhD supervision. And it might be worthwhile looking at these roles and responsibilities for HDR supervision from an agile perspective. We can just do a mapping between these roles and those that we find in HDR supervision. And from this perspective, the development of the dissertation, the written aspects of the thesis, the document, if you like, can be considered as a set of features. We've got theoretical features, methodological features, and so on. And these are organised into a product backlog, things that we need to have. So if we're looking at, for the time being, traditional agile approaches to software development or product and service development, then we have a product owner, a development team, and customers under a traditional approach. But what we're doing is delivering not a single final product, but actually bits of a final product. That's the multiple arrows in the second half of the slide B, panel B, where there's multiple arrows between the development team and the customers. This indicates that there's actually multiple packets of work, multiple packets of deliverable being provided to the customer. And the customer in this case could be the development team or the if you like, the HDR supervisory team. The development team is also the HDR supervisory team. And during examination, the customer will be the examiners as well. So there'll be a sort of slight shift in the way the roles are allocated. So when we're applying this HDR approach, this agile approach to HDR supervision, we get some role changes. So the supervisory team assumes the development team role and also behaves a bit like a customer. There are some other aspects to this that change, but the most important thing is the way we organise the work. So agile approaches try not to build a monolithic entity, a monolithic service or a monolithic software. And when we apply this to HDR supervision, the same thing should happen as well. we create value, or we create parts of the dissertation through sprints. So these are fixed length development cycles, generally a week or a fortnight. And at each sprint, we make sure that the HDR student knows exactly what they need to produce. It's something that we've negotiated as a team together with the student. We've planned what should happen in that sprint. And we have initially set our expectations, the expectations of the supervisors, low, so the students can meet what they're meant to do within that fixed 1 or 2 week sprint. Now, typically the team acts as a kind of a Scrum master, but sometimes it can be the principal supervisor. And what they're doing is making sure that the planning is conducted well and the student actually understands what needs to be done during their sprint. And what's also being maintained is a backlog of things to do, the product backlog as it would be called in Scrum, but we could think of it as something else, the thesis backlog, if you like. And each of the sprints that are successively conducted are intended to actually produce bits of that dissertation, bits of that thesis. So the idea is that we're moving items from this sprint backlog. The student is then completing them, and then we get to reflect on how well that's done. Oftentimes, to make sure that we know what's going on for any meeting or any kind of communication with the student, we have in effect a small Scrum meeting. It's a quick duration meeting, so that we can be sure that the student is still on the right track and doing what they need to for that particular sprint. So we can use Scrum as an analogy for this new way of thinking about HDR supervision. Often what is useful is to have a kind of board drawn up, and often supervisors have this anyway in their office. They have some kind of board with a list of things that need to be done, a list of new things that need to be done that haven't been done yet, sort of hangover from previous spurts of activity. And the arrangement of these items that have to be done and have been done and are to be done is often called a Scrum board. And so you'll often see columns being drawn up on supervisors' boards with particular kinds of things that need to be done. So we like the idea of using Scrum boards, and we conceive of the supervision as a kind of, in total, the thesis looks like a considerable number of tasks, the entire product backlog. A student for any given sprint, remember these are 1 or 2 week periods, maybe 3 week periods, has some subset of that product backlog, some set of that thesis backlog to complete in a particular sprint. So there is a selection of tasks in waiting, that's called a sprint backlog, and then the student moves each of these tasks into subsequent columns, part of the Scrum board. Things that have to be done, a to-do list. Things that involve building or writing, because we may have engineering students that actually build real stuff, or software developers who build conceptual stuff that executes on a computer, or we may have humanities students that are writing about concepts. So we have writing, we have editing, and we have these two things in succession until they move finally into a fourth column on the Scrum board, which is a done Scrum board. So items move from a sprint backlog to a to-do list. When we have capacity to do them, an item is picked from that to-do list and moves to the right-hand column where that particular part of the dissertation is written, and then it may be edited, and then it's put into a done board. And the idea is to move all of the sprint backlog items over to the right to the done board so that we can sign off that sprint. So sometimes we find that we have tasks which are too large. We really do attempt to make each task doable within a sprint, but sometimes we're not successful in scoping the size of that task. So what really needs to happen is it needs to go back into the product backlog, or the thesis backlog as we might call it for HDR purposes, and we need to reconsider whether that is one task or a number of tasks and whether it involves its own sprint or not. We try not to move things to the left, always flow to the right. That way we progress. If we have to backtrack, that means that we have had a problem in estimating the difficulty of a task. Reconsidering that backlog, that thesis backlog, reconsidering that particular task improves subsequent sprints, but we try not to have delays caused by throwing tasks back into the thesis backlog. So, to sum up, items flow from left to right. We have a to-do column that consists of all the items that constitute the sprint backlog for a particular part of the thesis. Once the team's ready to handle the next item, it gets moved from the to-do column into the build right column. Once we've written or built what it is that we're doing, we need to move that item to a test and edit. We make sure that what's been developed actually matches what's required. And then once we feel that it's complete, it gets moved into a done column. So we have a continual flow of items. Some items propagate through quickly, some take a bit of time. But we have limits typically on the capacity of how many items that we can deal with at any point in time. This is something that's very crucial, that we should not overwhelm ourselves with by having almost immediately a backlog occurring or bottleneck occurring in the build right column, for example, because we considered quickly a whole bunch of items and we just shoved them into the build right column, and we find that we don't have the capacity to actually complete each of them and move them to the right. So this whole notion of a pull system is something that we find in the discipline of operations. We find it in areas like supply chain and operations management. The idea comes from a manufacturing context where each item is pulled in succession. From a current stage, a selection is made from the items in the previous section, and from an item's perspective, the pull operation moves it through successive stages. So we try and diagram it this way. Any unfinished items, and those are items that were allocated to a current sprint and in a current backlog, but we couldn't complete for some reason, are unfinished items, and we need to move them at the end of the sprint back into the thesis backlog, the product backlog. They may need to be decomposed into multiple items. Unfinished items returned to a product backlog or a thesis backlog are by definition waste. This is a failure to estimate the complexity of an item. The other thing we might want to look at is, how do we know when a particular task is completed? This has got a technical definition. It's called definition of done, or DOD. And this was proposed by Sutherland, the person who sort of formalised Scrum. And it's used to describe when an item is complete, and we know that it's complete. So it's a good idea to have in the back of our mind an idea of how do we know when we've actually completed a particular task.